Hey guys, I'm Remy and I'm going to be explaining a real-life physics concept to you guys. So, I'm standing 5 meters away from my dog Biscuit and I'm going to be throwing this ball at a 35-degree angle and she's going to catch it. And then I'm going to explain to you how to find the max height of the ball in the air using an energy approach. Okay, ready, Biscuit?
So the first thing we're going to do is set up our scenario. So this is 5 meters from me to Biscuit, and we're going to use the triangle method. So in this method, this is our distance, this is velocity initial times time, and this is 1/2 acceleration times time squared. So this is our basic kinematic formula for distance, which is d equals v naught t plus 1/2 at squared. And then our next step is going to be to set up our system schemas, since we are going to be using energy to solve for the max height. So before we do that, I'm just going to explain the two basic forms of energy. We have gravitational / potential energy, which is energy that is stored and has to do with height. And then the formula for this is mgh. So this is mass times gravity times height. And then we have kinetic energy, which is when something is in motion and has to do with velocity and speed. The equation for this is 1/2 mv squared, 1/2 mass times velocity. So once we have that, there's one more important concept with energy, and that is that energy is conserved. So this means that energy can't be created or destroyed. So the energy we have in the beginning, or our initial energy, is going to be equal to our energy at the end, or our final energy. And this is the symboling that we're going to use for energy initial and energy final. And now is when we're going to draw out our energy pie charts. So to start with, I'm throwing the ball, which means we're going to have kinetic energy. And at the end, when Biscuit catches the ball, we're also going to have kinetic energy. So what happens up here is what we want to focus on. So there's obviously height, which means there's gravitational potential energy, since there's stored energy and the object has the potential to move downward. So there's this energy. And then there's also some kinetic energy. And this right here is what we're going to focus on. So instead of using our final energy, we're going to be using our initial and our max, which is up here, since we want to focus on the max height, and the gravitational energy equation is the one with height in it. So now our next step is to solve for the time. And to do this, we're going to be using trig functions and equations, and we're going to start off with tangent. So tan 35 equals 1/2 at squared over d. And the reason we're going to be using tangent is because we know this variable, and we know all these variables except for time, and we want to solve for time. So plugging in, we get tan 35 equals 1/2 negative 9.81, because our acceleration is gravity, t squared over the distance, which was 5. And this gives us the time to be 0.85 seconds. Now the next step is going to be to solve for our initial velocity. And if we go back to our triangle drawing, we can see that this vector is the one that has v naught. And now we can use cosine, because that's 35, I forgot to write that in, because we know this variable and we know this variable, so all we have to solve for is the v naught. So cosine of 35 equals 5 over v naught 0.85 gives us v naught is equal to 7.18 meters per second. So now we have enough knowns to solve for energy. So we're going to be using energy initial is equal to energy max, so at the top. So over here, we're going to be using 1 is equal to 2. So our energy kinetic is going to be 1/2 mv squared, and our energy max is going to be energy kinetic, so 1/2 mv squared plus mgh, because if you remember, this circle is split and has both gravitational potential energy and kinetic energy. So we don't know the mass of our ball, but that's unimportant because we have the ability to cross out all the masses. Since they're equal, we can divide. Now we're going to plug in what we know. So 1/2, our initial velocity was 7.18 squared. And now you might say, but wait, what would the max velocity be? Well, now we're going to create a second triangle that's going to look the same as our first triangle with the same angle. And this is called a velocity triangle. So this right here is going to be the 7.18 meters per second. And this is v naught x, so the initial velocity in the x. And this is the initial velocity in the y. And we're going to use cosine of 35 to solve for this v naught x value, which gives us v naught x is equal to 5.88 meters per second. And this is the value that is going to be the velocity when the ball's up here. So we're going to plug that in for here. So this would be the velocity max. And this is 5.88 squared plus gravity. And here it's important to make sure that your value for gravity is positive, since energy cannot be negative, times our height. And that's what we're going to solve for right there, our height. So once we plug that into our calculator and solve for all our values, we get h is equal to 0.86 meters. So that's our answer. The max height of the ball while in the air is 0.86 meters.